Hi, everybody. I hope you're doing great. I think my son's telling me to be quiet because he's watching Frozen. Okay, so we are on page 8. Today is the 29th. If you guys are watching with the dates that I post, there's going to be 2 videos for today just because I've been recording these videos together and they've been deleting on me. So I wake up at like 5 a.m. and then I have no videos to show for it. So that hasn't been too great. But okay, so we're going to finish up these 2 pages. That'll be one video, and then you'll have another video for 6.3, and those should all technically be watched today if you are keeping pace. Okay, so let's get it going. Okay, so you randomly select 36 cars of the same model that were sold at a car dealership and determine the number of days each car sat on the dealership's lot before it was sold. The sample mean is 9.75 days with a sample standard deviation of 2.39 days. Construct a 99% confidence interval for the population mean number of days the car model sits on the dealership lot. Okay, well, let's go through what we have here. So the 36 is your N. The 9.75 is your sample mean, so that's the X bar. And then the sample standard deviation S is 2.39. And then C is 0.99. Okay, so let's go through our checklist. So step 1. So do we have sigma? No. So that's unknown. Okay. Randomly, so we have a simple random sample. And then N equals 36, which is bigger than or equal to 30. So the central limit theorem applies, so we're good there. So all of this is showing us that we're going to have a distribution because we don't know sigma. Okay, and then the degree of freedom is n minus 1. So it's 36 minus 1 or 35. Okay, cool. Step 2. So now we have to find the critical value, the t-square, or t, whatever it's called, the t-value. Okay, so the degree of freedom is 35. The level of confidence is 0.99 or 99%. So let's look in our t-table to see what that gives us. Okay, so we don't have 35, but we do have 30. We always go with the lower one. Okay, and then 99%. Okay, so it's 2.750. Okay, so it's 2.750. Cool. So now we're going to find, I did click that. Now we're going to find the margin of error. Which is E. So that's T sub C times the sample standard deviation divided by the square root of N. So E is 2.750 times 2.39 divided by the square root of 36. Okay, so let's see what that is. So I got E is approximately 1.095 ... Okay, so since these are all rounded to the hundredths place, I'm going to round this one to the hundredths place. So look to the right, rounds up, so I get 1.10. Okay, now I can make my confidence interval. So it's the population mean that we're doing. So we're going to do x bar minus E and x bar plus E. So we're going to have 9.75 minus 1.10, which is less than mu, which is less than 9.75 plus 1.10. So we get 8.65, which is less than mu, which is less than 10.85. And then we just interpret this. So we're going to say with 99% confidence, you can say that population mean, which I'm just going to denote as mu to simplify it down a little bit more, of days on the lot is between 8.65 days and 10.85 days. Cool. And that's a wrap. Okay. So now on the next page, this is what we're going to use to tell whether we're going to use a normal distribution or a t-distribution. Okay. This is kind of like, I don't know if you ever read those books where they have like different endings, like you could choose different paths, you could have different endings, but I was just like so curious, I'd just like read all the endings. I don't know. I don't know. Those were a thing when you guys were younger, but they were for me. So the first question you're going to ask yourself is n greater than or equal to 30? Okay, and we're just going to stick to the yes side first. Okay, there is going to be a no, but we're going to stick to the yes side first. Okay, because there's a lot more on the yes side. So then you're going to ask yourself, is sigma known? So do we have that population standard deviation? If we don't, then it's a t-distribution, which means we're going to have degree of freedom be n minus 1, and then E is t sub c times s over square root of n. Okay. Now, if sigma is known, then we're going to use the normal distribution where we're using z-scores. So it's E equals Z sub C times sigma over square root of n. Okay, because we will have sigma in that instance, okay? Now, let's say we got no. So then we have to say, is the population normally distributed, normally, or approximately normally distributed? Okay, it would have to say that somewhere in the question. Okay, if it's, if yes, then you'd go to here, ask yourself that. Okay, if it's no, then you cannot use Z or T. Okay, it like basically you won't have enough information to figure that one out. Okay, nice. So we're going to actually use this in order to figure out this example. So in example number 4, you randomly select 25 newly constructed homes. The sample mean construction cost is 181,000 and the population standard deviation is 28,000. Assuming construction costs are normally distributed, should you use the standard normal distribution, the t-distribution, or neither to construct the 95% confidence interval? For the population mean construction cost. Explain your reasoning. Okay, we're not really going to explain our reasoning. I'm kind of just going to like go up here. I'll just say C, C above. And I'm actually going to go through and ask myself the questions so that you can see where it ends up. Okay, so is n bigger than or equal to 30? Nope, it's 25. Okay, so we're going to have to go to the no. Nope. Highlighter. Okay, so we're going to have to go to the no. Okay, so then we have to ask ourselves this question. Is the population normally or approximately normally distributed? It says that they are normally distributed, so we would go to yes, which means we ask ourselves, is sigma known? So do we have the population standard deviation, which it does give us the population standard deviation is 28,000. So that is yes. So we would have to use the normal distribution. Okay, so I'll just write down here. So that's kind of how you use that. Normal distribution. Okay, cool. So remember, there's going to be 2 videos for today. Make sure you're checking those out. Otherwise, have a great weekend. Talk to you soon. Bye.